So in today's session, we will be discussing the DB scan algorithm. So the DB scan stands for density-based spatial clustering of applications with noise. So as the name is indicating, this is the algorithm which will create clusters because you can see the term clustering here. So this algorithm is responsible for creating clusters from the available group of points. So one more important aspect you need to note down in the name here is density based. So it is based on the collection of points in a given area, which is called as a density. So more the number of points within a specified area, more the density. Less points, less density. So one more aspect you need to note here is noise. Okay. So this algorithm will even take into consideration noise points. Okay. Noise points are the points which are not part of the cluster, which are outliers that we had discussed in many of the previous discussions. So you can see in the very first point, DB scan algorithm creates clusters, forms clusters based on the density of the points. Okay, so density is collection or group of points in a given area, as already mentioned. More the density, more closer the points will be. So that is the first point. So the more sparse the points are, lesser density. More sparse means the distance between the points within a cluster is comparatively larger. So if that is the case, the density of the cluster will be less. For example, I have a cluster with a radius of 2 centimeters. So I just have 3 points. So it's a sparse cluster because less the density of the cluster is very less. The number of points in the cluster is very less. So that is the meaning of sparse here. So we need to be familiar with two terminologies here with respect to the DB scan algorithm. The first one is the epsilon, and the second one is minimum points. So what is the epsilon here? So as I already told you, a cluster is a group of points. So epsilon defines the radius of the circle within which you will find the group of points. So as you can see here, we have a point A. Okay. So at a epsilon distance from point A, which is the radius here, so we have drawn a circle. So epsilon is the radius of the circle. So the next term or next input that you will give to the algorithm is the minimum points. So it is the number of points that should be there within a circle, within the epsilon radius of the circle, okay, to qualify as a core point or a cluster. Okay, for example, I declare that within this circle there should be some 3 points, minimum 3 points. So you can see apart from point A, so two more points are there. So this constitutes 3 points within the cluster, within this cluster. And in that case, we declare point A is a core point. Okay. For example, I declare minimum points is equal to 3, meaning that within an epsilon distance from point A, I draw a circle, and inside this circle, if there are 3 points, okay, 3 points apart from point A, then I declare point A as a core point, okay, a core cluster. Once again, I'm repeating. You can see in this representation, in the representation below, I have point A. From point A, within the epsilon distance, I have drawn a circle. Okay, and within the circle, you can see two more points are there, B and C, totaling to 3 points. So point A, point B, and point C. So minimum 3 points. So I had defined to this algorithm that if minimum number of points equal to 3, then A will be taken as a core point, should be taken as a core point. The same has been done. Now, what if point A is not a core point? When it does not qualify to be a core point? So if the number of points are less than minimum, okay, then it does not qualify as a core point. For example, you consider within this circle we only had 2 points A and B. Just now, for time being, we'll assume C was not there. We just had point A and B. I had declared the minimum number of points as 3, but only 2 points are there, meaning that my point A, from which I had drawn a circle with epsilon radius. So within the circle there are only 2 points A and B, meaning that now A does not qualify to be a 4 point. So a specific point in a cluster with the epsilon distance qualifies as a core point if they are more than or equal to the minimum number of points. So we saw two terminologies here. One is epsilon, the other one is minimum points. The third one was the core point. So one more terminology will be introduced here called as boundary point. So this is the one, boundary point. What is a boundary point? We will see the definition of boundary point in the next instance. So what is a noise point? A noise point is a point that does not fall within the cluster. For example, I have some point here somewhere outside the cluster. So in that case, these points will be declared as noise points. Now, getting back to boundary point. What is a boundary point? So any point which is a neighbor of core point is a boundary point. To be more specific, I'll directly go to this example. Okay. Now consider this point R. Assume these are the points existing on the plane. So it is starting from here P. So P, R, S, and this is one more point. Okay, I'll call it as N, noise point. Now consider this point R. Now can I declare this point R as a core point? That's the question. Already we have seen the criteria for declaring a specific point as a core point. And I can declare point R as a core point only if within the epsilon distance radius, okay, I'm drawing a circle, and within the circle if there are minimum points as specified or as given as input to the algorithm. Assume that the minimum points are 3. Okay, now you just check how many points are falling within the circle. So R is the first point, S is the second point, you can see it is there within the circle, P is the third point. Okay, 3 points are there within the circle. So now I can declare point R as a core point, because as per the previous statement we had seen, a point P or a point R can be declared as a core point if it has the minimum number of points as defined in the algorithm within the epsilon radius. So now this was the story of point R. Also, I mean, it's not like there is only one core point. There can be multiple core points. Now I will go to the next point, point S. So now we are sure that point R is a core point, no doubt about it. Now we will go to point S, and within epsilon distance as radius, we will mark a circle here. So put a circle. This is a circle. Now check how many points are there within the circle. See, this is epsilon, this is not a point. Epsilon is the radius, distance. So how many points are falling within this circle? As you can see, it is 1 S. The second one is R. 2 points are there. Now, can I declare S as a core point? So it is a question. So as per the previous discussion, point S does not qualify to be a core point. What is the reason? The number of points within the circle with S as the center. So only 2 points are there, but as per our declaration, it should be 3 points. So S does not qualify as a core point. Now, if it is not a core point, then what is the term I need to use for this point S? So we can declare S as boundary point, but There is one more small condition to it. You can declare S as a boundary point only if it includes any one of the core point, okay, other than yes, obviously. Okay. For example, I have drawn a circle here. You can see within the circle there is one more point R, and that is a core point. Once again, I'm repeating. Any point can qualify or can be declared as a boundary point if within the epsilon radius there is a core point. So this example specifically matches with the definition for S, meaning that point S or the circle with point S in the center has a point R, and we know R is a core point. So now I can declare point S as a boundary point. It qualifies as a boundary point. So once again, when you can call a point as a boundary point, so you can refer this point or this statement. Point S does not have 3 points, yes. So we cannot call it as a core point. That's what I told you. But since within the epsilon radius of S, we have a core point R, we have this point R, so we can call S as a boundary point. So please try to recap. We can call a point as a core point if it has number of points equal to minimum points or greater than it. A point can be called as a boundary point if if a core point falls within the circle. Now, so we completed what is a core point, what is a boundary point. So we have one more term here called as a noise point. What is a noise point? Okay. The same thing. I have some point here. I'll call it as some Q. I have taken the epsilon radius. I have drawn a circle. Okay, but within this circle, neither I have a core point nor a boundary point. And in that case, such a point is called as a noise point. It's a complete outlier. Okay. Neither it has a core point nor a boundary point. Okay. Such points are called as noise points. That is what I have written here. Point which is neither a core point nor a boundary point is a noise point or outlier. Now, what is the major feature of this algorithm? It's a very robust algorithm for what identifying noise. So I have a data set with huge collection of data points or records. My fundamental objective is I want to identify noise in the data, outliers in the data, which may not be part of the cluster. So in such a case, this algorithm will serve my purpose very effectively, very efficiently. Now we saw three terminologies. One is core point, boundary point, and noise point. Apart from the two more terminologies which are input to the algorithm, which is epsilon and the minimum number of points. Now, our actual topic of discussion is forming or creating clusters. Okay. Now, who will be part of the cluster and who will be pushed outside the cluster? So, obviously, core points will be a strong constituent of a cluster. It will be there inside a cluster. Okay, no doubt about it. Core points will be there. Now, the question here is, should we include the boundary points or also as part of cluster? Okay. Now, some boundary points here. Should I make it part of a cluster? So the answer to this question is yes. So boundary points will also be part of the cluster because they are close to the core point. Okay, we will not eliminate it. Now, who are the ones that will not be part of the cluster? So the noise points. Okay, for example, this point will be called as a noise point if within the epsilon radius after drawing a circle. So after drawing a circle, I could not find any other points.